So we'll talk about that, but the basic thing is, let us understand that where does friction come from, where is this force which is originating from. Okay, so first of all, the force which is opposing relative motion or tendency of motion, this is known as the friction force. Okay, now in this case, that means the two objects always need to be in contact with each other. If there is no contact between the objects, there is no friction. Okay, it acts tangentially along the surface in contact. So basically we get to know the nature of friction, that how does it apply on the different objects. So it's basically a surface force which is always applied on the surface. So for example, I have a box like this, okay, and I am applying a force through its center of mass in this direction. If I want to technically draw this diagram in a correct way, in that sense, if I want to show the friction force, that friction force will be applied like this along the surface, because it's always applied along the surface. Okay, this friction force will not be along through this center of mass or maybe from the top of the object. This is basically wrong. Friction force will always be applied along the surface like this. Okay, so that's your friction force. Now it exists in pairs and acts on both the surfaces. Okay, so we'll talk about that, but before that we need to understand something called as interlocking. Okay, so this is something that you have already learned in your lower classes, but let's just revise this. So basically, any surface in this world, okay, that is never perfectly smooth. So for example, I draw a line. Let's say this line is the surface of the, basically a surface of any object. In this case, you can clearly see this line is not perfectly straight, right? It's not perfectly smooth. Okay, so on a molecular scale or on an atomic scale, you can clearly see basically there is going to be these rough surfaces. Okay, so it's like a jigsaw puzzle. Okay, so in this case, if I zoom into this specific contact surface, okay, of the surface and of the box, I can clearly see the surface is a little bit rough like this, and this box is also a little bit rough like this. Now because this box has its own weight, so it's pushing downwards, as a result these two roughness of the surface interlock with each other. Okay, so this thing is called as interlocking. Okay, so as I said, this is something like a jigsaw puzzle. Basically, if I have something like this, this is a one part of the jigsaw puzzle and the other part is like this, which is attached to it, right? Something like this. Now if I want to pull these two basically objects apart, right, if I apply a force in this direction and this direction, it's very easy to pull them apart, right? But let's say what I do is I apply a force in the upward direction and on this one on the downward direction. So I'm trying to pull this apart in this way. So because these two surfaces have interlocked with each other, they are going to apply an opposing force which will resist in the change in motion of these two objects, right? Because they have interlocked with each other. Something like this is already happening with all the surfaces which are in contact with each other. And why is it happening? Because by the nature of the surface itself, it's never perfectly smooth. Even the perfect glass that you see that it's very smooth, actually there are some irregularities. For example, the mobile screen, it feels very smooth on our fingers, but still there are irregularities on a very molecular level. Okay, so here because of this interlocking, there is the force of friction which is basically opposing to unlock these interlocking. Okay, now as a result, this force exists in pairs. It must exist in pairs. How? For example, I'm applying an upward force on this object like this. So when I am applying a force on this object like this, so this object will apply a downward force, that is, let's say, the force of friction on this. But this object is also getting pulled down, right? So this object will be applying an opposing force on this object like this. You can apply the Newton's third law as well, and by this logic as well, you can clearly see that the two forces are going to occur in pairs. So there is going to be a friction force on this object as well, on this object as well. This is the friction force of the black object on the blue object, right? Black on blue, let me denote by L. Okay, and this is the force of the blue object on the red object, right? F of the blue object on the black object. So L and B. Okay, so these are two opposing force. They occur always in pairs on the two surfaces, and they're applied on both the surfaces. Okay, so this is basically the force of friction, how it occurs.